Hello everyone and welcome to the internet. Good to see you here. I hope you're having fun. Good job on discovering the internet, by the way. It was a tough nut to crack for me about 2 decades ago. Anyway, the awful intro out of the way. Today I wanted to share some of my knowledge, I guess you could call it that, about making VFX in Unity, specifically VFX graph, and more specifically Unity 6. I've started using Unity 6 only recently, so I've been experimenting with it for the most part. Nothing too serious, and I just wanted to add a bit of my knowledge to the magnificent amount of tutorials that already exist out there on how to work with the VFX graph. It's not going to be anything serious. It's going to be a very simple saw blade ripping through the ground effect that uses some custom-ish functions and sort of sets you up for when you want to do these effects in the future to make something perhaps a bit more complex. There are a few prerequisites that we're going to be using, some custom model and a few custom textures. You can download them on a zip from the description, but they're all actually freely available. Sawblade, the one that I'm using, I actually downloaded from the free mesh database. I'm going to leave a link down in the description. You can download this and many other very simple models without any textures, of course, if you just need something very simple. As for the textures, it's a very simple ground texture, right? Very simple metal texture and very simple blurred line, motion blurred line that we're going to be using for some sparks. Again, you can make these or download them for free in about 3 minutes, but if you don't want to do that, you can download the entire comprehensive bout in the description below. So without any further ado, let's actually jump into making the effect itself. So the first thing that we're going to do is delete this because we don't need that. Let's get a VFX graph. This surprised me when I first opened it. In the previous version, you just got the default one, but now you can actually make something from the onset. We're gonna go with the minimal system. You don't need anything more than that, and just call it I don't know, wind cutters might be the most appropriate name for this, because it's gonna be pair of saw blades just rushing forward. Next, we create an empty object in the scene, call it VFX tutorial wind cut. Reset the position just for brevity's sake. Add this and let's open it up. So I presuppose that you have some knowledge of working in the visual effects graph. So you know the basics, you know how to do a setup, you know how to use custom properties. In case you don't know how to do that, you should still probably be able to follow this by just copying me one-to-one. But I'd still recommend going out and checking some more basic visual effects graph tutorials, because this thing here is a power tool that can do almost anything you want until you go to the super advanced stuff where you're probably going to want Houdini. But up until then, it can do pretty much everything you want. So there are a few things that we gotta change. For starters, we gotta do output mesh because we're gonna be using a custom mesh. So let's output mesh unlit, very standard. We're not gonna be using any fancy shaders or anything like that. We're just gonna use the custom saw blade. We're gonna set it to opaque, and for the texture, we're gonna do the ground texture that not the ground. The metal texture that we have. The ground is for something else. It's for another mesh output. Why did it say? Yeah. Okay. So next up in the spawn system, I'm gonna be using single burst. It's gonna spawn 2 of them, right? We're gonna set size in the initialize particle. Not in the update, in the initialize particle. Let's actually do this. It's gonna be about 2. We're also gonna set angle, so we need them to angle. So we're gonna do set angle. I'm not sure what, I think it's Z. Yeah, it's Z. It can be minus 90, 90, it doesn't matter. So as you can see right now, there's an overlap between our 2 meshes, right? We have 2, but no matter how many you set, even if you set 150, it's still gonna make it seem like there is only 1. The way to separate them is through a very nifty tool called a get particle ID. You're going to be using this a lot when you want to pre-position multiple particles in a particular way. So when you're doing something like a spiral effect or a circular effect or a vertical effect where you need particles to stack on top of each other in a very specific way, you're going to be using getParticleID. There's other functions for it, but don't worry about it. This is not a comprehensive overview of nodes or anything like that. So a very simple way to do this is to just divide it, right, by a number. You can make this float a custom, so you can customize it in the inspector. For the purposes of this video, we don't need to do that. And then in setPosition node, you just input this in whatever axis you want to separate them at. So because we're using this orientation, we want to separate them along the x-axis. So you input this into x-axis, and voila, look at that. We have two separate particles divided by a unit. Now, if you increase this to 150, it's still going to do the exact same thing, right? It's going to divide every single particle by whatever float you assign to it. We don't need 150 of those, we just need two for the time being. Let's say we want to decrease or increase the size between these two. You just move the float, right? Smaller one gives you more distance, bigger one gives you smaller distance. I'm going to go about 0.6 because I want there to be some level of separation between the two. So, what's next? The easiest way to animate movement of the blades is to actually just do a very simple add angle in the update particle. So adding. By the way, if you can't see add or multiply over stuff and you can only see set variations of these, you gotta do is enable this, right? Just click this right here because this enables subvariants of the existing ones. So we add angle, and what this does is simply animates the particle along an angle with the assigned speed every frame. Obviously, we don't want to do that in z-axis. We don't want to do that in y-axis, right? We want to do that in x-axis. So this spins the saw blades in a forward-seeming motion. Now, you wouldn't really see this that well if there wasn't a texture. So if you want even a more pronounced version of this, rather than using a relatively detailed saw model, you can do something like a shuriken model where you have 4 edges, right? So the apparent angular movement of the saw blade would be much more pronounced. We don't want them to be moving in this direction though. They're kind of rotating backwards, if you can see. So you just do -1. But what if I want to speed it up? Say I want to start slow. I want it to start slow, but I want it to speed up. So I want it to end up at like -50 or something, where it's like supersonic fast. Well, we can do that too. We just gotta do a few shenanigans here. So we're gonna be reusing our set angle up here, and we're gonna be doing some curve magic. So delete or just disable for the time being add angle in the update particle. We're gonna do is sample, if I could type, sample curve. Sample curve is one of those nodes that you're gonna be reusing a billion times over the course of VFX making because it's useful for basically everything. So let's set up the curve that we actually want. So we want it to start at -1. Right, we want it to start spinning kind of slow, but then we want to spike it super hard, super quickly to like -10, let's say that. So it's gonna start at -1, but it's gonna spike to -10 super quickly. Maybe we can actually do some magic of delay, so we can flatten this key right here. So it's gonna spike super fast. Right, but then we want to speed it up even further over the curve's lifetime, so we go to -15, and then towards the end we want it to be spinning at -30, though you probably won't be seeing this that well because it's going to be off in the distance somewhere, right? So what happens if you just input this into the X? Absolutely nothing happens. Because A, you can't animate this in set function by just sampling the curve, but even if you input it in the add angle function, so we go here, we sample the curve into add. It's just going to continuously spin on the first frame because you didn't modify the time. Now, if you manually modify the time, it's going to spin whatever the curve is set. So at 0.33, which is hereabout, right, which is hereabout, it sets this angular speed. The way to animate this is to just do something relatively simple, which is take total VFX time, multiply it so you can control how quickly something happens, multiply it by any one number, feed this into the time, and now when you input this into add angle, right, it spins, but we gotta slow it down a little bit, right? We gotta give it a bit more headroom. Let's say 0.2. So it starts slow and then it spins up fast. Now, obviously this is not perfect. I don't want to get it perfect. The way you would make this look perfect is you would work on the curve, you would fine tune it so it sort of gains acceleration rapidly, but also looks kind of realistic. For the purposes of this video, we don't need to do that. This is completely fine. This is completely fine. One thing that we gotta do is move it, right? We want the particles to actually move, or meshes in this case, to actually move. The way to do that is you could do set position, but that's not what we are doing here. We're gonna do set velocity. It's gonna be velocity on z-axis. And in our scenario, because this is the axis that I want to see them move at, we're just gonna do -5. So they're moving, they're going them everywhere, but that doesn't look that good, right? We want to sort of match the movement of the particles, of the meshes, with their angular rotation. And we do the exact same thing we did here, literally. You can just copy this, right? You can just copy this. Obviously, you gotta rework the curve a little bit. So we start at let's say 1.3. We accelerate relatively quickly to about -3. And then we accelerate even further to about -5. And then we can add some more acceleration, maybe -10. Obviously, we're going to fine tune these by the way it looks. And you can just go to the end and say -15 and just delete this key right here. So it does that. So now if we input this into Z, as you can see, it starts slow, but it gains some speed, a little bit, maybe. No, wait, you gotta do it this way. I keep forgetting that you gotta set it into the update. What happens is that the saw blade starts spinning slowly and then starts spinning fast, so angular rotation kicks up. We can slow display rate down a little bit. It starts slow and then it starts spinning quickly. And as it starts spinning quickly, it sort of starts boosting away at a higher z-axis acceleration. So we're pretty much done with the saw blades themselves. Obviously, this is just a showcase to you guys how you can get an effect like this working. Now let's make it pretty. Let's do something fun with it. Let's say we want to have some dust behind us. Or rather than dust, let's say we want to make rocks fly behind us. Now, we don't have rock meshes, but we can just repurpose cubes for the sake of, visual brevity. And in your scenario, you can just replace cubes with your rock meshes that you have. So let's say we want to have a simple particle system, which is spawn, right? Initialize, update, and output mesh, just a simple unlit mesh. So for starters, the way you would do it in this way is to literally sample the same positioning from this block here. So you would sample reiterations of where these are positioned along their acceleration path, which is a complicated math that you don't need to do because it's completely unnecessary. What instead we're going to do is something called GPU eventing, which is an effect, or rather a node, not even a node, it's a way to spawn particles into the game that you're going to be using a lot. Sorry about that, I needed some coffee. So you're going to be using this a lot. This is, if you ever use Shuriken particle system, this is sort of the emitters version of that. So we delete this, not everything, oh my god. We just delete the spawn one. And in update particle, we add something called trigger on event. All right, so you have several trigger on events. You have on die, you have on collide, but we want one called over distance, right? You have over time, you have over distance, you have on die, you have always, you have on collision. You have billions of options in Unity 6 that you don't necessarily have in previous versions, but we specifically want trigger over distance. So now you add a node called GPU event, you connect the GPU event to initialize particle, you connect this to this. So now, let's see how it looks when we play it. You can't see anything. Obviously, you can see it, but we don't have a setup for this. We don't have anything for this. So let's create a setup. For starters, let's just make sure that we're using ground texture. It's gonna be opaque, and we're gonna be using some fancy ways to make this look a bit better. For starters, what we're gonna do is inherit if I could type, we're gonna inherit positioning from our origin particle. So what's gonna happen is that in every instance that our particle is supposed to spawn, they're gonna inherit the position of the previous two particles, right? Instead of manually calculating that distance, we just get the instance of their position in the world from the source itself. So now when we play it, you're still not gonna see anything because you can see it, but that doesn't look good. It just looks like crap. But this is essentially what we want, right? Now, one thing that you might be asking, okay, why does it keep spawning in the middle? We gotta fix that. Don't worry about it. We gotta fix that. We can easily actually fix that. So let's make these cubes a bit prettier. Let's have set size random. So we're gonna do some random sizing. Let's just do 2.5 to 0.2 to 0.5. Let's do something called multi-size over lifetime, which curves are your bread and butter. What this does is literally just tells the particle how to resize itself over its set lifetime. So it starts at the initialized size of 1, which is the size that we set in the initialized particle node block, and then it curves down along its lifetime, meaning that it becomes smaller and smaller. So we add a small dip to make it a bit smoother, and then we set that lifetime. Let's set lifetime random, right? Because we don't want uniformity there, to be, I don't know, between maybe 0.6 and 1.3. So let's see how it looks now. It still won't look good, right? But as you can see, it spawns and then it starts growing smaller. So let's make it prettier. What can we do? Well, for starters, we can actually add some movement to our cubes. As they are right now, they just spawn and stand there doing nothing, but we can fix that. But first, let's actually fix their positioning. The way to do that is to just sample X and Z positions and not the Y position. So, outside of your particle system block, get node called getPosition. One of those nodes that you're going to be using a lot once you start doing something more complicated. For now, we're going to do source, right? Because source is this, the position, X and Z position of this particular particle system. We want to inherit those values. So you extend that, you just do vector 3. You don't even have to do this, but for brevity's sake, I like separating that. You do X, you do Z, and then here in set position, you just plug this in. So now when we replay, hopefully, now you can control where the Y is. The reason why it still appears as though it's happening in the middle, well, we can actually fix that. We want to raise our blades a little bit because they're in the ground. So what we do is in set position, we just add about 1, right? So we elevate them above the ground a little bit. So now when we play it, as you can see, they're spawning where they should, right? They still don't look good. They still look kind of bad, right? Well, we can fix that. For starters, we don't want just one of them to spawn per distance. We want to crank that up. Let's say 100, Let's go big, baby. We also need to increase the capacity a little bit, right? So now when we play, as you can see, there's a whole lot of them. It still looks ugly, but we can fix that. Let's actually give a bit of lift. There we go. Now it looks much better. So let's actually start moving these cube meshes. Should we? Or rather, shall we? The way to do that is set velocity. Set velocity is your bread and butter, but we want to make it random, right? So we want to move them in the opposite direction of our saw blade. So if we look over here and we see set velocity, oh, we're moving in the positive curve, or rather negative curve along the z-axis. So that's the movement of our saw blades. We want to move the cubes themselves in the opposite direction, which is the positive z-axis. So let's say we want z velocity to be something between like 2 and 5. Let's start small, just sort of to see what this effect has. So you can see it starts moving them rapidly backwards. Still looks more like dirt rather than ground being kicked up, but if you were making dirt smoke effect, this is basically where you would just start your finishing touches on the particle itself. You would be kind of done with the math of it all. But for cubes, there are still a few refinements that we can make. For starters, we don't want them to just be kicking back in a straight direction. We want them to be kicking back in X and in Y axis. So let's do that. Let's give some upward momentum and let's give some sideways momentum. We actually want to do -2 and 2. So now, as you can see, they're sort of being kicked up everywhere, you know? They're sort of being kicked up everywhere, but it doesn't look that good, does it? Well, for starters, we actually gotta lower the size a little bit to about 0.15 and 0.3. Right now, it's all about prettying it up. It still looks kind of like smoke, but don't worry, we're going to get there. We're now in the refinement process of fixing how this looks. So how do we make it so that this actually appears like a cube? For starters, let's actually go to 100 so I can see what it looks like in real time. It looks good. It looks good. They're being kicked up upwards well enough, but they don't live long enough to fall down, and they're not falling down because they have this acceleration of going upwards. So let's increase the lifetime to about 0.6 and 2.3, and let's do magic called gravity and collision. So in the update particle, we're going to add gravity. So when you have this gravity, what's going to happen is that they're just immediately going to fall down, right? But we want to give them a bit of a leeway, so we're going to say -7 instead of the default -9. So now they do fly up a little bit, but they still fall down through the ground, and that's all we want. Next up is the magic of collision, but let me first give me some cup of coffee. Or rather, sip of coffee. So collide, and now you have a bunch of collision shapes. You have spheres, you have cylinders, you have SDFs, which are the meshes, custom meshes that you can optimize for the collision. So if you're doing something super complicated, like grains of sand falling down on an arm, or any effect like that where you need like more precise collision of particles, you're going to be using SDF. We're not going to be using that today. That's a very, very complex down the level effect. For now, we're just going to be using a simple plane. So without any different factors, let's just see what it looks like. As you can see, it bounces. It bounces. Let's increase the lifetime a little bit more. Let's say it's between 2.5 and 3. Right? Look at that. Oh my God, it looks kind of good, doesn't it? Why does it look so good? It's the magic of VFX. Let's actually slow it down so you guys can see it a bit better. What you can actually do is increase the lifetime even more, and then just set some lifetime loss on the bounce. You can also give it a bigger bounce if that's your type of the floor. As you can see, they're bouncing back. But let's make them even prettier. Let's make them even prettier. So let's add some chaos to the... Right now, as you can see, they're all oriented in the same direction. They're facing the same direction. They're angled the same. So you can see where I'm going with this. In the initialize particle, we can just do set... If I could do that, that'd be great. Set angle random. right? So we do minus 360, 360, and maybe on X 360 and 360. As you can see, now they're oriented in different ways. But what if we want to add some spin to them, baby? Let's add some spin to them. Well, we do the exact same thing we did over here with add angle. That's basically it. So in the update particle, we say add angle, and let's also randomize it. On Y, let's say -1 and 1. And on X, let's say -1 and 1. And on Z, -1 and 1. Sorry. So now when we play it, as you can see, they're rotating a little bit, but not too much, right? We can fix that. Let's just move them on X-axis, right? So, oh no, let's just move them on Z-axis because we're setting the, yeah, my bad. So, we do this and this. So now, as you can see, they are spinning. They are rotating it around. You can obviously fine-tune these values to make it look more realistic. You can turn the unlit version of the mesh into a lit variant so that it takes light. Let's actually do that. Let's just quickly do that. Let's say out mesh lit, right? So what we do is it's going to be opaque, right? It's going to be ground. Let's do this. Let's do that. Right? So we can lower the smoothness. We can increase the metallic of it. So it doesn't look as good, right? Because the texture itself is not primed for lit environment. It doesn't have a normal. It doesn't have any mapping. So it's just a default texture of any kind. But you can do that. Like if you have your rock, right, and you have normal textures for it, you can do the lit version of it. I'm just gonna keep to the simple unlit variant because this is just for showcasing the effect a little bit. So we are kind of done with the rocks. Obviously, you could refine it even further through the magic of fine tuning. But for the sake of like moving on and keeping this short, let's move on, right? Because you have the setup for the basic effect, and now you can refine it on your own by adding color, alpha fading, some emission maybe. Let's actually do the sparks, right? Let's do the sparks. As the saw blade moves, let's say it has sparks. Now, you could just create a simple system as we did before and do the exact same thing as we did here, but we could just duplicate this over yonder down here and change a few parameters to make it look different. So for starters, we're not going to be outputting a mesh. We're going to be out particle quad, unlit, very simple. It's going to be an additive, and we're going to be using this specific whatchamacallit texture. So let's actually just feed this into the GPU event immediately to show you how it looks right now. It doesn't look like sparks, do they? They don't look like sparks. They just look like random particles. We can fix that. We can fix that. So first and foremost, we don't want collision, we don't want gravity, and we don't want add angle. Let's see how it looks with that. It looks kind of a bit better, but not really. We also don't want to set random angle. We don't want lifetime to be so big, so we want very short lifetime. Let's see how it looks now. Okay, we're getting there. It looks marginally better. It looks marginally better. But we actually want to do this. So we want to inherit the set position. No, we actually don't. No, we don't. But let's do that. Okay. Okay, we're gonna figure it out eventually. For now, let's just make sure that the sparks look Good. No, actually we want to do it here. No way, we don't. I don't know why that happened. We're gonna figure it out. We're gonna fix it eventually. So let's actually make sure first that the sparks themselves look good. The way to do that is to orient them along their travel position. So there is a very nice, neat node called face camera plane. Orient face camera plane. So just inputting this, not face camera plane. Oh my god, along velocity. I'm sorry, it's very early in the morning. My bad. So orient along velocity. So now the individual particles are going to angle themselves toward the direction of their travel. So now, you know, it looks a little bit better, but we're going to make them look like sparks. And the way to do that is to set angle. Let's actually just do it in the output. So set angle. So which angle should we change in order to make them look like they are facing downwards? Is it X? Is it Y? Is it Z? It's Z. So on Z axis we do 90, right? But it still doesn't really look like Spark because we gotta do set scale. We gotta do a random one. So what set scale does, it crunches the individual particles along whichever axis. So let's say we want a very small x, so 0.1 and 0.2, they become very tiny, right? But we want to actually extend them to make them be a bit longer along the x-axis, but on the y-axis we want them to be very tiny, right? So something like that. So we have our sparks, kind of, maybe make them a bit shorter, so 0.8 and 1.3. There we go. So we have our axis, our sparks traveling along the proper axis. Obviously we got to change the moment a little bit. So set size is fine, but lifetime is gotta be super small. So we're talking 0.5, 0.1, but velocity, there's not going to be any change on x-axis. There's going to be a higher degree of velocity on z, and especially on y. So we want to kick them up really quickly, right? So let's say 5 and 8. So let's see how it looks now. Okay, they're invisible because they don't live that long. Let's increase the lifetime to about not 1.5, oh my god. 0.15 and 0.3, 0.2. 0.1. Okay, yeah, so that's much better. This is what it looks like, and it's actually perfect. You can add some randomness to it by introducing turbulence or gravity or vector field in the update particle, but for the sake of this particular whatchamacallit, for the sake of the tutorial, I'm not going to do any of that. I figured out why it keeps staying here is because I don't have the get position. Sometimes it's the simple, most of the time, honestly, it's the simple things, right? Most of the time it's the simple things that you just overlook. So now sparks are appearing. They're invisible though because of the thingamabob, because of the rocks, but we can make them stand out a bit more. We can do that by saying set color over life. We're going to be using the alpha as it is, but let's give sparks some pizzazz. So let's make them glow, right? Let's copy this color toward the end of its lifetime. Let's paste it, but say that they glow at just 2. So now when you play, as you can see, they're a bit more visible. They're a bit more visible, but there is still some magic to be done. So let's rename these quickly. So sparks, rocks, and saw blades. Right? So we can do this to completely hide them, right? But what you can do is just lower the size of the rocks to make them little, to make them stick out a little bit less. So something like that is a bit better, right? So we want to crank the Y vector on set position a little bit more, to 0.3. No, this is the one that is already cranked. There we go. Obviously, you could do a bit more to change this, because if you play it at full rate, it doesn't necessarily stick out. The sparks themselves aren't really that visible. But you can increase the lifetime just a smidge, so maybe 0.2 and 0.15. So they become a bit more visible. But the point isn't really for sparks to be visible in so much that they're just sort of there. And when the player is playing, they can actually see the sparks. Now, this is basically the effect done. I skipped over making smoke because I forgot about it completely. But the way you would make smoke is literally the same exact way you would do all three of these things. It's just that you would use a custom smoke texture with lower alpha and a bit more turbulence, where the smoke disperses along the wind or gravity or what have you, and doesn't have any collision, of course. Then you would probably change the saw blades themselves a little bit. The way we can do that right now is to just do set color. We're going to keep it white, but what you can do is just increase the emission a little bit to make them glow, right? Maybe give some like brownish taint to them. So now they look just a smidge better, right? And you can also just increase the number of things that spawn as they move, right? So this is essentially the effect done. I hope you guys enjoyed it. The goal wasn't so much to give you a super cool effect that you can copy one-to-one, but to just sort of give you a framework of what an effect like this, how an effect like this is made. So then you can go into VFX Graph and you can just polish the crap out of this, because the most fun thing about VFX is when you get to that polishing stage where you have all the functionality and now it's just about making it look pretty. You would maybe use a custom shader for the saw blades and maybe for the ground. Maybe you have some parallax mapping in place where you wanna make it seem like the ground is actually being cut as the saw blades move. So the way you would do that is to using a custom shader with parallax mapping on it, where you would have specific textures that match the ground. Maybe you could do some matching with the code where you have specific textures for the specific world type that you have. But that obviously is a lot more complex, it's a lot more involved, and it's that refinement stage that takes the VFX from looking like indie game VFX to, AA or even AAA VFX. And it's probably better to just do that in Houdini, if I'm being completely honest, because it's a lot simpler. You don't have to do any custom parallax mapping and parallax shader math, which can get super convoluted, and it isn't always the most optimal way in terms of performance to do these things. But yeah, that's for the future. For now, I hope you guys enjoyed it. It looks bad. In the game, obviously, there is no world setup or anything like that. I hope you enjoyed it. And thank you for watching the video. I hope you enjoyed it, and I'm gonna see you guys some other time with some other custom tutorials. If you want any kind of a tutorial, please let me know in the comments and I'm gonna try and make it. If you have something you're confused about in regards to this tutorial, if I skipped over something a bit too quickly, let me know. If something isn't working, I'm gonna try my best to help you. So thank you for watching, and I'm gonna see you guys another time. Jesus Christ, this went on for so long.